Explain construction of Moore type distance relay with a figure. So you can visualize in the figure, this is the internal construction of a Moore type relay. The heart of the relay is a lightweight, hollow, cylindrical rotor. This is called as the induction cup. It is usually made up of aluminum to ensure low inertia and fast operation. A stationary iron core is placed inside the hollow cup to decrease the air gap reluctance, ensuring the magnetic fluxes pass efficiently through the walls of the cup. The stator consists of an electromagnet with projecting poles, typically 4 poles arranged in a cross shape. This is not shown here. These poles house the different windings necessary to create the magnetic flux that will spin the cup. So here you can visualize these are the 4 poles. These are 2 poles, this is 1 pole and this is another pole. Now these 4 poles are having windings over it which is made up of copper. Operating winding is typically wound on the one of the poles, that is on the left side here mentioned here. This is the left pole. It is energized by the line current which is coming from the secondary of the current transformer CT. The flux from this winding interacts with the polarizing flux to generate the operating torque which tries to close the relay's trip contacts. Now polarizing contacts, here you can visualize these polarizing windings. These are usually wound on the 2 opposite poles, that is the top and the bottom poles here. They are energized by the system voltage from a potential transformer PT. Often a tuning capacitor, you can visualize this tuning capacitor is connected in series with the winding to provide memory action. This memory action is necessary for the keeping relay stable during the closing faults and to create the necessary phase angle shift for torque production. This winding provides the reference flux for the relay. Now restraining winding. This winding is wound on the remaining pole, that is the right hand side pole here. It is also energized directly by the system voltage. The flux from this winding interacts with the polarizing flux to generate the restraining torque, that is the opposition of the operating flux, which holds the contact open during the normal operation, and when faults are outside the protection zone, the relay is non-working state. Relay is in non-working state, means won't operate. A small control spring which is made up of phosphorus bronze is attached to the moving assembly. It provides a constant initial mechanical restraining torque to keep the contacts open when the relay is de-energized and to prevent false tripping from minor transients. The moving induction cup is mechanically linked here to a moving contact. Here you can visualize this. It is connected with the moving arm or say moving assembly. When the operating torque exceeds the combined electrical restraining torque and mechanical spring torque, the cup rotates, closing the contacts to send the trip signal to the circuit breaker. So this is the basic details about the construction of Moore type distance relay.